All right, this is Unit 4, Lesson 2, Graphing Rational Functions. So my lesson essential question is, how can you graph a rational function? At the end of this lesson, you will be able to graph rational functions. So let's go ahead and take a look. Example number 1. I want to rewrite a rational function to identify its asymptotes. Okay, so I have rewrite g of x equals 4x over x minus 3 using long division. How is the quotient related to the reciprocal function f of x equals 1 over x? Sketch the graph. So I divide 4x divided by x over 3, so I get 12. So I get 4 plus 12 over x minus 3. I write the remainder as a fraction in the quotient. Okay. So when I graph this, in the graph, the parent function f has been shifted up 4 units, up 4, and then right 3 units. The resulting graph has been stretched vertically by a factor of 12. There is a vertical asymptote at 3 and a horizontal asymptote at 4. Okay, so I want to use long division to rewrite each rational function, use the asymptotes of f, and sketch the graph. So I have 6x divided by 2x plus 1. Okay. So I have 6x over 2x plus 1. Okay. 2x times 3 gives me 6. So 3 times 2x is 6x. 3 times 1 is 3. Subtracting. 6x minus 6x is 0. I have a 0 up here. 0 minus 3 is negative 3. So when I write this, I get 3 plus negative 3 over 2x plus 1. Okay. So the 3 tells me that I have a The 3 tells me that I go up. Plus 1 tells me that I go right. Left, sorry. Okay. So this tells me I go up. This is a horizontal asymptote at 3, and I have a vertical asymptote at negative 1. I need asymptotes and then sketch the graph. So I have x equals negative 1, y equals 3, and then there's a stretched value of negative 3. Okay. So if my equation is y equals 3 plus negative 3 over 2x plus 1. Okay, I can pick values for x. So let's go with 1. X times 2 times 1 is 2 plus 1 is 3, negative 3. Let's see, we said 3, up 3, 1. There's my horizontal and vertical asymptotes. Okay, so that gives me at 1, negative 3 over 3 is negative 1, so 3 minus 1 is 2, so 1, 2. All right, so this is actually going to be flipped because it's negative. So we said 1, 2. So here's 1, 2. That's where that one is. And then if I go negative 1, nope, that won't work. I do negative 2. So I do negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. Negative 3 divided by negative 3 is positive 1. 3 plus 1 is 4. So negative 2, oops, negative 2, 4. Actually, it's really close. Okay. So there's my asymptotes, negative negative 1/2 and 3. So remember 2x plus 1. So this minus 1 does tell me that I moved to the left, but I had to divide that by 2. All right, so I want to use long division to rewrite each rational function, find the asymptotes of f, and sketch the graph. F of x equals x divided by x minus 6. So I'm going to go ahead and graph those points. Okay, so 1 times x gives me the x minus 6. I'm subtracting. X minus x is 0. 0 minus negative 6, so plus 6 gives me positive 6. So I have 1 plus over x minus 6. So again, this 1 tells me that I'm moving up, and this minus 6 tells me that I'm moving to the right. So my asymptotes then are x equals 6 and y equals 1. So x is 6. 6, y is 1. So there's my asymptotes. Okay, my equation is y equals 1 plus 6 over x minus 6. Okay. So if x is 0, 0 minus 6 is negative 6, 6, so that's 0, 0. There's one of them. And then if x is negative 12, let's see, negative 12, nope, doesn't work. X is 6, 6 minus 6 is 0, that does not work. So if I do x equals 12, 12 minus 6 is 6, which gives me 2. So 12 and 2, so really, really close to this. That is right, okay. There we go. Okay, so here is 12. Goodness, I can actually do this. X is 12, so 12 is over here. There's 12, that's 11. 12 is right here. X is 2, about right. Okay. So vertical asymptote at 6, horizontal at y equals 1. And then my graph, 6, 1. They picked 8 and 4, and 4 and negative 2. Okay. Same graph though. All right, concept, rational functions. Just as a rational number is a number that can be expressed the ratio of two integers, a rational expression is an expression that can be expressed as a ratio of two polynomials, such as p of x over q of x, where the value of q of x can't be 0. Okay, so again, dividing by 0, bad things happen in math. A rational function is any function defined by a rational expression, such as r of x equals p of x over q of x. The domain of r of x is all values of x for which q of x does not equal 0. The function g of x equals 4x over x minus 3 is a rational function. All right, so example number 2, how do you find vertical and horizontal asymptotes of the irrational function? What are the vertical asymptotes for the graph of f of x equals 3x minus 2 over x squared plus 7x plus 12? So vertical asymptotes can occur at the x values where the function is undefined. I determine where the denominator of the rational function is equal to 0. So basically I set this x squared plus 7x plus 12 up to be 0 and I solve. Okay. The possible vertical asymptotes. Okay, so I factor this out, I get x plus 3, x plus 4, so x can be negative 3 or x can be negative 4. So the possible vertical asymptotes are x equals negative 3 and x equals negative 4. I graph the function to determine if there are asymptotes at x equals -3 and x equals -4. I can use the trace feature on a graphing calculator to confirm that the graph is not defined at x equals -3 or x equals -4. So the graph is not defined at those places, so these lines are vertical asymptotes. Okay. So what are the horizontal asymptotes for the graph? So to identify horizontal asymptotes, we can consider three cases. So first case, the degree of the numerator is less than the degree of the denominator. So consider g of x equals x plus 4 over x squared plus 1. As the value of x increases, the value of the denominators gets very large in relation to the numerator. The value of the function gets closer and closer to 0. When the degree of the numerator is less than the degree of the denominator, there exists a horizontal asymptote at y equals 0. So for the function f of x equals 3x minus 2 over x squared plus 7x plus 12, the degree of the numerator is less than the degree of the denominator. It has a horizontal asymptote of y equals 0. Case 2, if the degree of the numerator is higher than the degree of the denominator. Okay. So if this is true, there's no horizontal asymptotes. Okay. And then finally, the degrees are the same. Okay. So if the degrees are the same, I use long division, and that tells me where my horizontal asymptote is. So in this case, when I divided, I got 2 out in front, so that's the horizontal asymptote of 2. When the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is the ratio of the leading coefficients. Okay, so less, it's at 0. Bigger on top than the bottom, it doesn't have any. And if they're the same, we divide to find. All right, so what are the vertical and horizontal asymptotes of the graph of each function? So I have 2x squared and plus x minus 9 over x squared minus 2x minus 8. So vertical, I set x squared minus 2x minus 8 equal to 0. Okay, so when I get this, I get x, 4 and 2 give me 8. So minus 4 plus 2 equals 0. So x equals 4 and x equals -2. Okay, so when I graph this, I can see that there's one at -2, and it looks like there is one at 4. Those are my vertical asymptotes at x equals -2 and 4. My horizontal, they are the same. Okay, so remember, when we're back over here, case 3, if they're the same, I divide. Okay, so when I divide, 2 times this gives me 2x squared minus 4x minus 16. Subtracting 0, x minus this is plus, this gives me 5x, -9 plus 16. 7 gives me plus 7. So I get 2 plus 5x plus 7 over x squared minus 2x minus 8. This plus 2 is what we're looking for. It tells me that I do have a horizontal asymptote at 2. So there's one horizontal asymptote at y equals 2, and there are 2 vertical asymptotes at x equals -2 and x equals 4. Okay, so I have f of x equals x squared plus 5x plus 4 and over 3x squared minus 12. So again, I'm going to set that 3, so vertical, set 3x squared minus 12 equal to 0. I can factor out a 3. This is the difference of 2 squares. So that tells me x equals -2 and 2. So those are my vertical asymptotes. X squared plus 5x plus 4. So I can see that I have -2, like it comes right up to this line, and 2 again comes up to this line. So it does, I do have 2 vertical asymptotes there. Okay. My last one, I need to find the horizontal asymptote. So because these are the same, I divide. Okay. So I want to know what times x squared will give me 3x squared. Well, that's 3, which gives me, actually, what times 3 will give me x squared, which is 1/3. Okay. So 1/3 times 3 gives me x squared. 1/3 times 0. And then 1/3 times -12 gives me a -4. Of course, I'm subtracting. So I get 0, 5 minus is 5x. 4 minus -4 is +8. So I get 1/3 plus 5x plus 8 over 3x squared minus 12. Okay. So the 1/3, that's what I'm looking for. That's my horizontal asymptote. All right, example 3, graph the function of the form ax plus b over cx plus d. So I want to graph the function 2x plus 1 over 3x minus 4. So I do my vertical asymptotes first. So 3x minus 4 equals 0. So I have a vertical asymptote at 4/3. I do my horizontal asymptote next. I determine if there is one. Well, they are the same. So 2x over 3x gives me 2/3. So as x approaches plus or minus infinity, y approaches 2/3. So there's a horizontal asymptote at 2/3. So I have 4/3 and 2/3. Okay, then I graph the function. So I pick some points, choose x values, and evaluate, plot the points. Okay. So find horizontal, find the vertical, then graph the points. All right, so let's go ahead and graph this function. I have 4x minus 3 over x plus 8. Drag the points on the graph to change its shape. Drag the gray point to change the location of the asymptote. Okay, so I'm going to go ahead and go out a little bit. All right, so like we did in the example, I want to find the vertical asymptote first. So I set the bottom equal to 0. Well, x, so my vertical. So x plus 8 is x equals -8. So -8 is my horizontal. So 5, 6, 7. Okay, so there's 8 right there. Okay, they are the same. So 4x minus 3 over x plus 8. Okay. What times x gives me 4x? Well, that's 4. 4 times gives me 4x. 4 times 8 is 32. Subtracting gives me 0. -3 minus 32 minus -32. So this is actually plus 32. So 32 minus 3 gives me 29. So I get 4 plus 29 over x minus 8. This 4 gives me my horizontal asymptote. 4. Okay, so -8. 4. All right, so there are my 2 asymptotes. Okay, zoom in a little bit. All right, now I just pick values and I plot my points. See, 0, 3/4, 0. Need 14, 10. Okay, so that's roughly a couple points there. Check the answer. Very similar to what they have. Okay. All right, I want to graph the function g of x equals 3x plus 2 over x minus 1. I drag the points on the graph to change its shape. drag the gray point to change the location of the asymptotes. So vertical asymptote, x minus 1 equals 0, so x equals 1, so that's my vertical. So vertical is 1. Okay, then I figure out horizontal, so I divide 3x plus 2 divided by x minus 1. So I get 3 plus 5 over x minus 1. 3 tells me that I have a horizontal asymptote there. Okay, so horizontal asymptote at 3. 3. Right there. Now I get to pick some points. Okay, so there's my graph. Of course, I can check my. Okay, 1, 3. They pick 2, 8, and 0, negative 2. All right, example 4, use a rational function model. The cost of removing a pollutant is modeled by the given function where f of p is the cost in millions of dollars of removing p% of the pollutant. What percent of the pollutant can be removed for 78.3 million? Okay, so here's my model. Since p is a percent, you know that 0 is less than or equal to p, which is less than or equal to 100. Find the vertical asymptote by solving. 100 minus p equals 0, so p equals 0. Find the domain as 0 is less than or equal to p, which is less than 100. Graph y equals 78.3 and y equals 8.7p over 100 minus p. The point lies at 90, 78.3, which lies on both graphs. So again, I'm taking the 78.3, that's the percent, okay? And I'm graphing that, so y equals this, and then I'm also graphing this, y equals 8.7p over 100 minus p. You can also use x. Okay. So 90% of the pollutant can be removed for $78.3 million. All right, so let's go ahead and try it. New techniques have changed the cost function. For the new function, g of p equals 3.2p plus 1 over 100 minus p. What percent of the pollutant can be removed for $50 million? So again, my horizontal asymptote is at p equals 100. 100 is my vertical asymptote. So I'm going to go ahead and graph these. 50, and then 3.2p plus 1, 2 plus 1 divided by 100 minus p. Okay, so I graphed these, y equals 50 and y equals 3.2x plus p over 100 minus x. So again, I just changed the variables of p to x and g of p to y, just so that they would graph a little bit easier in Desmos. So when I graph this, I see my function. I also have this negative here, so here's my horizontal asymptote at 0. There's also a vertical asymptote at what looks like 0, but it's actually less than that. There actually is no horizontal asymptote. Okay, so I graphed the 50 here. So right here where these two meet is 93.96650. So that tells me that 93.9% of the pollutants can be removed for $50 million. Roughly 94%. All right, example number 5, graph a rational function. So what is the graph of f of x equals 4x squared minus 9 over x squared plus 2x minus 15? So again, I graph my vertical asymptotes. I have 2. My horizontal asymptotes, which I have 1. Okay. and I graph the function. So pick a couple points, which they did, graph my function. Okay. Identify the asymptote and sketch the graph. I have g of x equals x squared minus 5x plus 6 over 2x squared minus 10. So my horizontal asymptotes of 2x squared minus 10 equals 0. So I can factor out a 2. So I get x squared minus 5. So x squared minus 5 equals 0. So x squared equals 5. And I take the square root of x squared equals the square root of 5. So x equals plus or minus the square root of 5, which on a calculator is about 2.23606, blah, blah, blah. So 2.24 was x equals 2.24. So x is positive 2.24 and negative 2.24. All right, so then I have to figure out my horizontal asymptote. There is one because I have x squared minus 5x plus 6 divided by 2x squared minus 10. So what times 1 will give me 2? Well, 1/2 would work. So 1/2 times 2 is x squared. 1/2 times 10 is 5, so negative 5. Subtracting. So I get negative 5x plus 11. So I have 1/2 minus 5x plus 11 over 2x squared minus 10. So 1/2 is my horizontal asymptote. Let's see, oh, that's 1/2 right there. Okay, so there's my graph as of right now. Now I just need to graph the points. So here is what my graph looks like. So I have these points here. Here's my horizontal and vertical asymptotes. So vertical was plus or minus square root of 5. Asymptote horizontal was y equals 1/2. And then my graph. Okay, so I had these points here. Gives me this. All right, concept summary, graphing rational functions. So rational functions are a function that is expressible as a fraction with polynomials in the numerator and the denominator. So asymptotes, you have vertical and horizontal asymptotes. Vertical asymptotes are guides for the behavior of a graph as it approaches a vertical line. So the line x equals a is a vertical asymptote of p of x over q of x. If q of a equals 0, then p of a cannot equal 0. The up or down behavior of a function as it approaches the asymptote can be determined by substituting values close to a on either side of the asymptote. My horizontal asymptotes, are guides for the end behavior of a graph as it approaches a horizontal line. If the degree of a numerator is less than the degree of the denominator, so if I have x over x squared, it has a horizontal asymptote at y equals 0. If it's x squared, so say x squared over x, so greater denominator, there are no horizontal asymptotes, and if they're the same, you divide to find the horizontal asymptote. So in algebra, I have 8x minus 3 over 4x plus 1. So my vertical asymptote, I set 4x plus 1, my denominator equal to 0, and I solve. My horizontal asymptote, they're the same, so I divide. 8 divided by 4 gives me 2. And then I graph that. All right, and that is the end of Unit 4, Lesson 2.